Hello, class. Today I'm just going to go over the topics that are going to be on the test or that will be tested on. Off the request a bunch of times. Plus, we lost that Friday on the ice day, so that's kind of more why I'm doing this to make up some lost time. So let's go to the first topic right away. This is, I would say, your free points here. Change radians and degrees from here, if you need to change something that starts off of a radiant, so let's say like pi over 3, what you do is you multiply with a fraction. Since you're going 2 degrees, it's going to be 180 on top and pi on bottom. You also could think about it, the pi will naturally cancel out. So this cancels out, this 3 becomes a 1, this 180 becomes a 60. So your final answer is 60. Doable by hand also. So that's radians to degrees, and then of course the reverse is degrees to radians. So let's say 300. So 300, I'm just going to put it over 1 for easy sake, and I'm going to multiply that. Since I'm going to radians this time because I start at degrees, I'm going to radians. It's going to be pi over 180. Okay, you can cross out the zeros, so it's 30 over 18. You could take out a 6, so it's 3 and 5. Yep, so it's just 5 pi over 3. All right. So easy points, that's the free space on the bingo card. Next one, finding the trig value. Now, finding the trig value. Now, everything else is going to be the tough part because this requires you to know one of two things. You need to know for a fact your special right triangles, which is 45, 45, 90, and 30, 60, 90. Not only you need to know these things, but you need to know how it works in a unit circle. So if your hypotenuse is 1 in the special rectangle of a 45, 45, 90, this would be 2 root 2 or root 2 over 2. And this would be root 2 over 2. And over here, it would be 1/2 and root 3 over 2. We went extensively in class about how this becomes and the math behind it. With that in mind, with that information, you could fill out any of these angles that matches the 45, 30, or 60 with sine, cosine, or tangent. So let's say if I ask you, let's find cosine. Let's do 5 pi over 6. So 5 pi over 6. First off, you might want to think of it as degrees to help us out, but get used to this. This power 6 is or the base 6 is going to help you out in a different way. But there's two ways to think about it. First is cosine 5 pi over 6, which is the same as 150 degrees. So what's actually happening? Let me talk about what's actually happening. So we have an angle. Starting here, it goes 90 degrees. And then I go an extra to make 150. I need another 60 degrees, which means I have a line from here to here. This point from here to here is going some measurement. And I need to know what this theta down here is. This theta in the bottom, it always comes from the x-axis, I should say. So if it was like upside down, like this, like is the theta here or here, it's going to always be on the bottom. Or I'm sorry, it's always going to be next to the x-axis. So you always make your theta next to the x-axis when we talk about angles within the quadrants. Okay, so either way, this is 60 degrees, which means what's left over is 30 degrees. So that is what we call our little reference angle. This is what I base all my information from. So you could pull out the table or you remember it by hand, that's fine. But sine, cosine, tangent for a 30-degree angle or 33-degree angle is going to be 1/2. How do I think about it as 1/2? Because if 30 degrees is down here, this has to be the smaller piece. So this has to be 1/2, while the longer piece on the bottom should be root 3 over 2. So cosine's root 3 over 2. And tangent would be sine over cosine. You could do the math yourself, but it's going to be root 3 Wait a second. Root 3 over 3. No, yeah, root 3 over 3. But that is y over x or sine over cosine. That's sine, cosine, tangent. So we find those, and then we just use the reciprocal. So sine is 1/2 root 3 over 2, or root 3 over 3. Cosecant is 2. Secant is 2 root 3 over 3. And cotangent, if you reciprocate this, is just root 3. Again, I'll leave the actual arithmetic to you if you don't know it. Now, I mentioned in the earlier, this 6 tells me something. When it comes to radians, if you have a base, let's do these three. Base 3, base 4. Actually, let's do it like this. And you'll see this in the table we made in the past. I don't know if I mentioned it at the time, but pi. So if you look at the table, pi over 2 always corresponds to a 90-degree reference angle. Pi over 3 always responds to a 60-degree reference angle. Pi over 4 always responds to a 45-degree angle. And pi over 6 always responds to a 30-degree angle. So all these angles represent this type of reference angle. So when I look at 5 pi over 6, which is why I also figured out it's 150 very quickly, I didn't actually do the math. I just figured out it's in the second quadrant and it has to be referenced to the 30. So since 5 pi over 6, I just see the little 6 here. Wait a second. I can figure out 6 is always related to 30. And with 30 degrees, sine is always a half. Cosine is always root 3 over 2. And tangent is root 3 over 3. There's multiple ways to remember this, either by creating it along the time or remembering the table or using the radians to help you remember what reference it is. And I almost forgot the final piece, which I'm sure a lot of people said while I was doing this. This is in the second quadrant. So all students. So it's in the second quadrant. That would mean that only sine should be positive. So this should be a negative cosine. This should be a negative tangent. This should be a negative secant. This should be a negative cotangent. Why is that? Cosine represents the x value. Since you're going left on the graph, that must be a negative x value. And then tangents y over x. Y over x, which means it's a positive divided by a negative, which means it will result in a negative overall. So sine, cosine, tangent, cosecant, secant, cotangent. So I could give you just a radian like that. I could give you it as a secant. The question was though, what is 5 pi over 6? Cosine 5 pi over 6. That would be negative root 3 over 2. I did, I guess, additional, but I could have a question where I ask you for all of them. Okay. So that's the more straightforward one. In the previous one, this is me giving you something in the trig that are in the whatever trigonometry, so cosine, and you just pull out a number. This is straight up, hey, do you know your unit circle type question. This one, finding a trig ratio when given the other point of trig ratio, this is more, a little bit more thinking about the triangles themselves versus the unit circle. So for example, let's say if I want secant of theta when, and it's going to be familiar to our last lesson too, tangent of theta equals, let's say, negative 5 over 3. Negative 5 over 3, yeah, that's fine. At a point and is in quadrant 4. Okay, so give me secant when tangent is negative 5 over 3 and is in quadrant 4. And you're probably thinking, why does quadrant 4 matter? Well, first, let's think about this. I know tan equals 5 over 3. So I know tan equals 5 over 3, but more importantly, or very importantly, maybe not more importantly, it's negative. In order for a tan to be negative, it must be in the first quadrant or the third quadrant. So in order for a tan to be negative, it has to be here or here. And this is the first quadrant, second quadrant, third quadrant, fourth quadrant, if you need help with that. So it has to be either in 2 or 4. But because in the question I specifically said, hey, it has to be in quadrant 4, then it has to be in quadrant 4. So because it has to be in quadrant 4, I'm going to make a triangle coming out of quadrant 4. I have some theta. I don't know what it is. And honestly, in this question, I'll never know what it is. But I have tangent is -5/3. Another way you could think about it, because some people get confused like that, put negative in front maybe. So it's -5/3. So with that in mind, you're going downwards here, right? If you're going downwards, that means the y value must be negative. It's opposite over adjacent. So opposite of the theta is -5 over the adjacent, which is your x value, which is always your cosine, is your 3. Not always your cosine. It's always your cosine in a unit circle. Always your sine in a unit circle. So this is 3, and this is -5. Now we need secant. Secant, which is the opposite of cosine, which is adjacent over hypotenuse. So we need to find cosine, and then we could just do the reciprocal, or you could go right to the reciprocal, doesn't matter. But either way, I have the adjacent, which is 3. I need the hypotenuse. So the hypotenuse over here is going to be 3 squared plus 5 squared equals, I don't know, c squared. Now, I always give you numbers that you can actually do by hand, so don't sweat. Like, the numbers won't get too big. 9 plus 25 equals c squared. 9 plus 25, 36. Does it actually work? No, it's 34, my bad. 34 equals c squared. So it's going to be c equals square root 34. My bad there. I thought I just found a new Pythagorean triple, but I'm just being silly. But here it is square root 34. So because this is square root 34, we know our hypotenuse is square root 34. But we're actually not looking for adjacent over hypotenuse. We're looking for hypotenuse over adjacent. So maybe I should put my answer here. Root 34 over 3. There's nothing grammatically wrong with this. There's no square root on the bottom. We all good. All right. Oh, wait. So that's one when I give you another trig function. So notice the trig value gives me a triangle that I have to use SOHCAHTOA for. So I could give you one where I give you a trig value and then you use that like to reverse engineer a triangle. And I could give you one that is just straight up a point. So give me all 6 trig functions at some coordinate point. Let's say like, let's keep it straightforward. 3 comma, let's do -3 comma 4. So I want 6 trig functions at -3 comma 4. So again, I'm going to visualize. You can also draw yourself a very small one on your test. A little XY graph. Now I'm putting a point. Let me not put the line there first. I'm putting some coordinate point over -3 left, up 4. So -3 over 4. So I'm putting some coordinate point there. Yeah, it's a little bit more left than it's up, whatever. So we're going to make a dotted line here, which means I went 4 up to get to this point, and I went 3 left. I'll call that -3, okay? And I need some hypotenuse over here, but you should be used to the Pythagorean triples. -3, 4. This is going to end up being 5. Well, wait a second. Your theta is always off the x-axis. So looking at this, wait a second. We all have our adjacent, hypotenuse, and opposite, or adjacent, opposite, and hypotenuse. So that means we're going to do our 6 trig functions. So sine, should be sine theta. I think I might just write it out for you. Sine theta is opposite over hypotenuse, which is 4 over 5. Cosine theta, ca, is going to be adjacent over hypotenuse, -3 over 5. Tangent is going to be opposite over adjacent, so 4 over -3. So I'll make the whole thing negative. Then not only you have that, you have to do your trig reciprocals, so 5/4. This one's going to be -5/3. And this one's going to be -3/4. And this is cotangent, and this is cosine, so secant. Okay, so not too bad. The point is, I think, actually seems to be easier than this because you don't have to do the reasonable, like have to figure it out. This, you basically make the triangle knowing your x value happens to always be your adjacent, and your y value will happen to always be your opposite, which is kind of the reason why sine is always y, cosine is always x in a unit circle. I should put that preface that it's y when it's in a unit circle, it's x when it's in a unit circle. Okay, special right triangle, using a special right triangle. This is going to be a form of a word problem, and the word problem is going to be, I don't know, some piece of wood on a house or something. So it's going to be some form of word problem. Yeah, let's put a piece of wood there. And some grass. Okay. So, and the problem will probably say something like, you know, like a 30-foot piece of wood. Yeah, 30-foot piece of wood leaning on the barn at a, let's say, let's do a 30 degree, let's do a 30-degree angle elevation. How high up does it reach the barn? There's going to be some question like that. So first off, be able to model your question. So a 30-foot long piece of wood is leaning on the barn at 30 degrees elevation. How far up does it reach the barn? Something like that. So from here, you're like, I can use SOHCAHTOA. But the problem is you don't have a calculator. So you can't actually use SOHCAHTOA in the traditional way. So, but this degree, this angle is going to be, because you don't have a calculator, it's going to be a very specific angle, whether it's 30 degrees or 45 degrees. With that in mind, because it's 30 degrees or 45 degrees, you know that your special right triangles. Hopefully, you do know your special right triangles. So I think earlier I said, do you need to know your special right triangles? Like, yeah, you do need to know it in a context. You also need to know it for the unit circle. But since you have to know it for this, I always suggest just knowing it for the unit circle. Let me actually rotate this thing. So it's this way. All right. So this one, I have a right angle here. This is 30 degrees. I got to remember my special right triangle, which is A. This is 60, root 3A, and then, or A root 3, I should say. And this is 2A. And in this particular example, I know my hypotenuse is 30. So since 30 equals 2A, divided by 2 on both sides, 15 equals A. This would be 15, and this would be 15 root 3. But since this is across a 30-degree angle, the answer here is 15. This is special right triangles. If you need help finding special right triangles, I recommend just using YouTube on that. There's an infinite amount of videos talking about how to solve a special right triangle. The only trick here is going to be forming the word problem, but I'm going to be straight up the word problem, some piece on the wood of a house. All right. Describe a transformation graph trig. Okay, this is the meat and potatoes. This is some of the hardest things for you. So I'm going to have two things. I'm going to have just describe the transformations, and then I'm going to have the graphing, which is the whole amplitude, blah, 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 blah. Actually, let me see what we got. Actually, I just realized, I'm sorry, guys, I have to get going. So I'm going to do, I'll say this for a separate video, my fault, or I'll link other videos. In that sense, I'm just going to do this. Let me just do arc trig kind of questions. I'm sorry, I'll do the graphing in the other video. So here, very quickly, you have you have the arc trig, which is the same as trig -1. So there's going to be like one question where you evaluate just the arc trig. So like, let's say arc sine equal of, let's say, a half. So arc sine of a half. So it has to, what results in a half? What results in a half when I plug in sine? Another way to think about it is sine to what angle gives you a half? Um, So arc sine and a half, sine what theta gives you a half. So you have to either call back from the unit circle, remember your unit triangles, know your unit circle like the back of your hand, but not actually be on the back of your hand, please. So I need the result that causes it to be a half. So a half over here. So that must have been a 30-degree angle. So that's going to be pi over 6. Okay. So I'm asking in the unit circle, what results a sine or y value in a half? Now, very important when you do arc sine, the number inside has to be between actually the number inside here has to be between -1 and 1. I don't think I mentioned this, but because I forgot like how it's like something simplistic. The number inside arcsine has to be -1 through 1. And I just want to explain why. The result of this will always be between negative pi over 2, negative pi over 2, sine, arcsine. Sorry, let me start again. Arcsine, what's inside has to be -1 to 1. What's results, the answer, or you could think of your range, is going to be from negative pi over 2, arcsine, to pi over 2. And then I did the other relationships on the notes, so look at that. I just want to talk about why does it have to be -1 to 1? Remember, in a normal sine graph, right? A normal sine graph, what's the range? 1, wait, this sine 0. No, it starts at 0, my bad. So in a normal sine graph, it starts at 0, goes up to 1, goes down to -1, goes up to 1, goes down to -1, goes up to 1, goes -1, yada, yada, yada. So the number in here has to be between -1 and 1, because if it goes above -1 and 1, that would mean there's some transformation, but the arc sign doesn't know that, so that cannot happen. So technically the number in here has to be -1 and 1. That won't be relevant to your test. I just have to mention that. I don't think I mentioned that in the class. And in your answer, though, this is definitely relevant to your test, is it'll be arc sine from negative pi over 2 to 2. So if I had negative a half, I need the negative between here and here. So I need negative pi over 6 in this case. Okay. So there's the just plug in arc sine or arc whatever, arc trig. The other ones are the relationships between a trig and an arc trig or inverse trig. So like, let's do, I'll use sine again. All right, cosine. Cosine of arc cosine of, let's do 1/4. Okay. Last time I showed you with the triangle, hey, you'll figure out what the opposite over hypotenuse is, but then go back. Since it's cosine and arc cosine, and you look inside here, just make sure it's between -1 and 1. If it's not between -1 to 1, this is impossible because arc cosine stops being a function. But cosine and arc cosine, because these are opposites, hey, since this is allowed 1/4, you could cross this out, and your final result will just be 1/4. Again, another free point. You can cross this out. Just always check if it's between -1 and 1. I'm going to be straight honest. I'm not going to trick you like that, but it should be -1 to 1. If I do make that mistake and you write no solution because of this, I'll give you extra credit. Okay, let's do, okay, now we're going to do the opposite. Arc sine of sine of, let's do 5 pi over 6. Okay. So first, arc sine 5 pi over 6. First, you need to do sine 5 pi over 6. This is when the arc is on the outside, so you don't just straight up cancel. You kind of cancel. You'll see in a second. So sine 5 over 6, 5 pi over 6, I think we did it earlier in the video. You go through all the reasoning, however you remember it. But it's going to be 30 degrees up, which means this is going to be a half. So now we have arc sine a half. Because we have arc sine a half, that is what theta causes sine to become a half. That is going to be pi over 6. So your final answer here is pi over 6. Why is it not 5 pi over 6? Remember, arc sine could only produce negative pi over 2, 2 pi over 2. So because it only could produce that, it has to be the one between negative pi over 2 and pi over 2, which is pi over 6. Sine over here is 5 pi over 6. I just want to make sure. Yeah. And then, what's inside is less than 1, so that makes sense. That's okay too. But arc sine and a half has to be pi over 6. So when the arc is on the outside, you have to think about what could come out of the arc sine or the inverse. We have that. And then the last one, which is kind of familiar, I just want to throw a callback to this one. And actually, I'll just use the same thing. Secant when tan is negative 5 over 3. Secant when tan is negative 5 over 3. Oh, wait, I messed up. Secant when arctan, my fault, is 5 over 3. Arctan is negative 5 over 3. So over here, we have secant arctan negative 5 over 3. The reason I called back to the previous problem, because mathematically, you kind of do the same. The only difference is with arctan. Oh, and you might say, but Mr. Tobo, is that bigger than negative 1 or less than negative 1 in this case? For tangent, it doesn't matter. For sine and cosine, it matters. For tangent, it doesn't matter. And the reciprocal is secant and cosecant, it matters. But here, because it's between 1 and negative 1, or it doesn't have to be between 1 and negative 1. Either way. So arctan is negative 5 over 3. Because we're using arctan, we need to know exactly which quadrant you're using. The reason I use arctan, because it could be confusing. Is it 2 or is it 4? In this case, because it's arctan, it's going to be between, or it's going to be in this area. Because it matches sine. Because it's in between this area, that means it's going to be in the 4th quadrant. So that means you're going to have a drop like this. Negative 5 is your opposite, so that's going to go down 5. And then you're going right 3. That's your adjacent, right 3. Again, your theta is always over here from the x-axis. The hypotenuse, which I think we found earlier, is root 34. So now I need the secant of this theta. I don't know what this theta is, but I do know what my triangle looks like. And I know secant is not, this is opposite cosine. It's not adjacent over hypotenuse, but hypotenuse over adjacent. Which means the hypotenuse, which is negative 5 over, or I'm sorry, the hypotenuse, which is root 34 over the adjacent, which is 3. And just as a reminder, this happens to be the same answer as the previous one when we did it a couple pages ago. Yeah. Did I say quadrant 4 there? Yeah, it did say quadrant 4. Okay. But it's going to be the same answer. So it's going to be root pi 34 over 3. Whether it's negative or positive, since this is cosine, and since we're going to the right, it makes sense as positive. Also, I use the positive 3 and the positive root 34. The hypotenuse is never negative. So because of that, it must be positive. Okay, as I said, guys, I have to apologize. I'm going to have to let this go. I have to do the graphing as a separate video. I have to take care of something today. Otherwise, use this to your advantage. Hope this helps. Sorry for the little bit of the either if I made a mistake or it wasn't very clear. That's my fault doing this in a short period of time. Make sure to study, use your own homeworks. Maybe I'll post some other homeworks. All right, see ya.